Hey, welcome back. Today we're going to learn how to machine this part here using Autodesk HSM CAM software. First, we're going to get familiar with some basic tool paths like 2D Adaptive, Pocket, and a couple more. Let's go ahead and get started. First thing you want to do is to open up the part that you made the other day here. Okay, so open it up with Autodesk Inventor, and at the top here you should see a CAM tab. So go ahead and select that tab and come on over here and select Setup. Okay. Once you select that CAM tab, we're going to do a new setup. So go ahead and do that. When we start a new setup, the first thing we want to do is to make sure our X, Y, and Z axes are orientated correctly. So I like to first always pick that back left corner. All right. And what we need to make sure is let's assume or pretend that this part here is in the vise in our machine. All right. So positive X should always be going to the right, positive Y should always be going away from us, and positive Z should be always pointing up. If your X, Y, and Z axes are not orientated correctly, you need to come over here and you need to select X and Y axes. Okay. You're going to want to select that line for your X. Okay. So you'd hit X and you'd hit right there. Or you want to select Y and you'd hit right there because this is the Y direction. All right. And if they're still not orientated correctly, then you can flip them, flip X and flip Y to make sure they're right. Okay. And once again, you can do the same with Z here. So you can select your Z plane too. Okay. You just hit this and you click like right there because this is our Z, this line right here, this white line. Okay. All right. So now that that's done, we come on over here to stock and we want to set up our stock size. All right. And we want to go over here. We want a fixed size box and we're going to want to make it 6.2. Okay. And we're going to want to place that in the center of our stock. And here we're going to want to change this to 3.2. And once again, keep it in the center. And for our Z, 1.2. And then keep it offset from positive Z, a value of 0.2. So think about what we're doing here. We're moving it from the positive Z value and we're offsetting it or moving it zero point 0.2 inches from the top of our stock. So we're moving it down. Okay, and I would encourage you to fool around with these and let's see what happens if we change it to 0.5. Okay, see what happens. We don't want it to go that far, so let's keep it with 0.2. Okay, and that's good. Down here at the bottom, let's go ahead now and click OK. So now we're going to want to do our first machining operation. And the first thing we usually do is a face. So let's come on up here and select face. This is going to give us a nice flat piece of stock to work with. And next we want to select our tool. So we're going to come on over here to tool. Under my libraries, okay, we're going to make a new library and let's just call it what the part is, base plate. Hit enter. Okay, and we're going to come on over here and we're going to go import tools from library. And I have mine on my desktop. Okay, um, right here. Okay, and then hit open. And now we have all of our tools. And the tool we're interested in right now for this particular operation is a face mill. And we want our 3-inch face mill here. So we're going to go ahead and select that. Okay, and if that pops up, hit OK. All right, now that we have our tool selected, our face mill here, we can turn off our coolant. Let's disable our coolant since we're just learning about the different tool paths for this exercise. One thing we do want to do though is make sure our spindle speed is at 5,000 and our feed rate is at 40, okay? And now let's come over here to the geometry tab and we're going to select the top of our part, all right? And unfortunately though, we want to get the whole top of our part, something that will go as wide as this line, okay? So we can fix that where it says stock offset, all right, we're going to widen this yellow boundary here by, let's just make it 0.5, okay, and let's go ahead and hit OK. It looks good. All right, and for our next operation, we're going to want to do a roughing pass, and that's going to be a 2D adaptive. So we're going to change our tool, come back to our base plate library, and we're going to select the 3/8 flatten mill and hit select. Okay. Once again, make sure coolant is disabled. We want 5,000 RPMs, and we're going to do a cutting feed rate of 40. All right, and for our geometry, we're going to come over here, and we're going to select that bottom line. So you should end up with something that looks exactly like this. Okay. All right, and the next tab we're interested in here is called passes, okay? And the value we're interested in here is called optimal load, also known as the step over. And typically, when a tool's cutting metal, you want about 20 to 30% of engagement of the tool with the material. So if we take 3/8 and we multiply it by, 0.2 or 0.3, that'll give us an optimal load of roughly around 0.1 or so. Okay, so we're going to give an optimal load of 0.1, okay? And this is a roughing operation. So the whole goal of 2D adaptive is just to remove lots of material efficiently and rapidly, but leave a little bit of stock behind, okay? And in this case, we're going to check stock to leave, okay? And we're going to leave 0.02, okay, radial and both axial stock, okay? Now, a word about smoothing. What smoothing will do is take basically your toolpath, and instead of a whole bunch of little straight lines, it'll convert those little straight lines into arcs and basically shorten up your G code. And so feel free to use it. It's never hurts, and it's a good way to shorten up your G code. But in this case, I'm just going to go ahead and hit it OK. OK, and notice it creates a toolpath for you. When we're done, we're going to simulate everything up here and make sure our part is machined correctly. But in the meantime, go ahead and pause this video and feel free to simulate it and see how your tool paths look or how they came out. But let's go ahead now and move on to our next operation. So up here, we're going to select, we're going to want 2D pocket, okay? And for our tool, we're going to come back over here to our base plate, and we're going to select the 5/8 flatten mill, okay? And we're going to hit select. And then we're going to take the coolant off. Once again, make sure we have a spindle speed of 5,000 RPMs and a feed rate of 40, okay? For the geometry, we're interested in this line right here. Make sure just that line is selected, okay? All right, now let's come on over to passes here, okay? One thing we want to check now is the maximum step over, okay? We're going to use a maximum step over of 0.2 inches, okay? And if you look at what step over is, it's basically the distance, okay, between our passes here. And that's what we want, okay? A 2D pocket operation is a roughing operation. So make sure you select stock to leave. And in this case, we're going to have to differentiate between our radial and axial stock. In this case, we want to leave behind 0.02 inches of material along the walls of our pocket. So to do that, we're going to change our radial stock to leave to 0.02. But we don't want to leave stock along the bottom of our pocket. So we're going to change this to 0. And that'll basically tell the tool to go all the way down to the bottom and not leave behind any stock. Okay, so let's go ahead and hit OK. And let's move it so we can kind of see our tool path here. So remember, our tool's going to spiral in here, and then it's going to make a wider and wider hole, okay? And eventually machine out this pocket. So the next operation is going to be a finishing operation, and that's going to be our 2D contour. So let's go ahead and select 2D contour here. All right, and we're going to change our tool here, and we're going to go back to the base plate here and select our 3/8 flat end mill and hit select. Okay, now when you're doing a 2D contour, okay, you want to slow it down. So we're going to use a feed rate of 20 and an RPM of 30. Typically, finishing feed rates and RPMs are a little slower to give you a better overall finish and appearance. All right, make sure your coolant is disabled. And now let's come on over here to our geometry tab. Okay, so if you recall, we left some stock, some raw material along this outer edge and along these inner walls. So let's go ahead and click there. And once again, click there. All right, and let's come to passes. Make sure your finishing feed rate here says 20 and make sure all of these are unchecked. We don't want to leave any stock. Okay, and that's it. And all these other default settings are good. Okay, and let's go ahead and hit OK. Okay, and when you're done, you should get a finishing path that will remove that 0.02 stock that's left behind here, and it'll get a nice smooth finish. Okay, and that is a finishing pass, our 2D contour. For our next operation, we're going to want to do a radius milling operation. Well, a radius milling operation is done with a 2D milling, a 2D contour path. So let's go ahead and select our 2D contour, come back over here to Tool, select our base plate, and in this case, we want this guy right here. And notice this sort of arc-shaped tool here. That's going to give us the fillet we want on our part. So let's hit select. Okay, once again, let's change it down to 3000 and give us a feed rate of 20. All right, under passes, or excuse me, under geometry, we're going to select right here. Okay, and under passes, same thing as last time. Finish feed rate says 20. Leave these unchecked and hit OK. Okay, and you should hopefully end up with the following toolpath. All right, so now we're going to learn some basic drilling operations. So let's go ahead and come on up here to drill. All right, and we're going to change our tool once again, come back over to our base plate, tool library, and we want to select the 3/4 inch 82-degree countersink drill. Okay, and hit select. All right, I'm going to rotate it so you can get a little bit better view of the drill. And let's turn our coolant off. And if I forget to turn it off, it should always be off. So in this particular case, we're going to go ahead and go with 3000 RPMs and a feed rate of 20. And here's where your plunger feed rate will matter. So we're going down, so let's just go with a plunge feed rate of 10. Okay. All right. And over here in geometry now, we want to select on these conical shaped cone parts. Okay. And that's pretty much it. We'll leave all the other default values in and we'll hit OK. All right. And when you're done, you should end up with a toolpath as such. Okay. All right. Our next operation is going to be a drilling operation again. So we've made these conical shaped pieces. Now we need to make the actual hollow portions going, the actual holes going through our part. So we're going to drill again. Okay. We're going to change our tool and we're going to come back to our library. And we want a 13/64 drill. Okay, when we drill a hole out and we're adding threads to it, we always want the drill to be slightly smaller than the actual hole. Okay, so we're going to select a 13/64 drill and we're going to hit select. All right, and once again, disable our coolant. We're going to go with the same RPMs as last time, 3000, and a plunge feed rate. Okay, of 10. All right, and then we can go with a retract of 40. That's fine. And then for the geometry, we're going to rotate our part around and we're going to actually select, okay, these holes here. And you may need to move them around just to see them there. And since this is a fairly deep drilling operation, we're going to want to come over here to our Cycles tab, and we're going to want to select Deep Drilling, Full Retract. Okay. And we're going to enter a pecking depth of 0.02 here. Okay. Now this is important because when you're drilling, the hole can be clogged with chips. So by performing a pecking operation, the drill will sort of bob in and out and remove some of those chips so it doesn't get clogged. All right, let's go ahead and hit OK. Okay, and here's our toolpath. All right, and the next thing we need to do is add threads to these. So to add threads, once again, a threading operation is essentially uses a tap, which is a special type of drill to add threads. So we're going to go to Drill. We're going to go back to our tool, base plate library here, and we want our 0.26 right tap. Okay, and that's actually incorrect. We need to change that. So we're going to come over here to cutter, and that should be 0.25. Okay, and hit OK. All right, hit select, hit OK. All right, disabled. We want a spindle speed, okay, of 3,000 RPMs. Okay, and once again, for our geometry, we're going to select our holes, these cylindrical walls here. All right, and then over here in the cycle tap, okay, we're going to select right tapping. Okay, go ahead and hit OK. All right, so we're getting close to the end here. The last thing we want to do is make this small slot, all right here in the middle here. Okay, so to do our slot, we're going to select our tool here. We're going to come back to our base plate and we're going to select our 1/4 inch flat end mill. Let's go ahead and hit select that. And we're going to use a 3,000 RPM spindle speed and a feed rate of 20. Okay. Now let's come on over here to the geometry tab and we're going to select this linear portion here in the bottom. Okay. And that should do it. I can't remember. Cooling is disabled. Let's go ahead and hit OK. And there we go. There's our slot operation. So our mill's going to come down and remove the material right down through the middle here. All right, so the last thing we want to do is engrave your name here on the part. And instead of using the actual engrave operation, I like to use the trace. It's just more easier to work with. So I'm going to select trace, and for the tool, okay, we're going to select our 45-degree chamfer, and we're going to engrave with that little tiny tip right there. So let's go ahead and hit select. Okay, we're going to change it, coolant disabled, 3,000 RPMs, and a feed rate of 20. Okay. All right, and now we're going to come on over to our geometry, and here's where we got to be a little careful. Okay, zoom in here, and we're going to select the bottom here of our part. Okay, and since we extruded it, remember when we made this, we extruded it 0.02 inches. So our tool path, our tool should go that deep if we're selecting on the inside here. Okay. And you're going to have to just do this for every letter. Okay, and that looks pretty good. Now, I want to point something out. We're going to keep our axial offset at 0, but let's say we selected the top part of our letters. Well, we could also send our tool here 0.02 inches into our part by this setting right here. But we don't need to, since we already extruded that 0.02 inches into the part when we made it. All right, but like I said, if we were to select this top part of it, We could also do that and set this to 0.02 inches, and it would tell our tool to go into the part 0.02 inches. Okay, so let's set that back to 0, and we're going to go ahead and hit OK. Okay, and there is our tool path. All right, so if you did everything right, now comes the fun part. We get to simulate it here. So select setup 5, select simulate. I'm going to orientate it in sort of a good manner here so you can see the full operation. We want to check stock, and we also want to always check stop on collision. All right, when you're ready, hit play. I'm going to speed it up a bit, okay, so you can see the whole operation. Okay, there's our contour, our fillet, our drilling, our pecking, and okay, here comes our slot, and then our name. Okay, so that should do it. Hopefully you did everything right. Go back and check. Do me a favor, take a screenshot of your final part being completely machined with your name on it and submit that as part of this assignment. All right, thanks for watching.